Friends, today we talk about the unit number 5th, design for manufacturing or design for X. Okay, in this today we discuss the introduction of the design for manufacturing and also the some part of the design of castings. Okay, let's start. Okay, first is called as the design for X. What is meant by the design for X? X is generally called as the dozens of the quality criteria related to the manufacturing. Okay, what are the quality criteria for the designs? Okay, here the figure shows there are the dozens for the different quality criteria, generally starting from the design for manufacturing, procurement, service, assembly, safety, disassembly, commonalities, reuse, environment, reliability, costings. These are the various quality criteria for the manufacturing also. Okay, today we discuss only focus on the design for the manufacturing and the design of the castings. Okay, now what are the classification of the manufacturing processes? In the design for manufacturing, we must know the what is meant by the manufacturing, what are the different criteria for the manufacturing, and what are the classification of the manufacturings. Okay, the types of the manufacturing process, we also know the what are the different types of the manufacturing. First is called as the primary process. All of you know this primary process. Generally the primary process consists of these forming process, in which the casting process or mold forming processes are comes under the primary manufacturing processes. Then second is the secondary manufacturing processes. Generally in these types we include these, or we categorize the different types of the machining processes. Okay, and third is called as the finishing processes. All of you know these finishing processes called are the part of the grinding, slapping, burnishing, super finishing process are comes under this finishing process. These are the three major, there are the three major one of three major types of manufacturing processes: primary, secondary, and the finishing for the manufacturing. Okay, now what are the classes of the manufacturing processes? We go somewhat deeps on the classes of the manufacturing processes. Okay, first is called as a casting processes. Okay, all of you know the casting process is the forming processes. You can give the shape to the component which we required. Then polymer processing, generally the molding processes. It's also called as injection molding or plastic molding processes. Deformation processes, you can deform the component to give the required shapes. These are the deformation process. Generally comes on in this category comes under these forging processes or the sheet metal processes. Then powder processing, nothing but is called as the powder metallurgy, sintering processes. Then machining processes, you can remove the machine from the process. Generally is the part of these negative process, negative manufacturing processes. Then joining processes, so is the weldings or brazings, soldering are comes under the joining processes. Then heat treatment is a special processes, and eighth one is called as assembly processes. The number of components comes together to form a complete components. Okay, what are the traditional design approach for the design for the manufacturing? Okay, the weakness of the traditional design processes is called as the product out approach or the traditional design process. Okay, what are the product out approach? Here is the there is no customer need identifications or latent needs from the customer. We directly go for the design and manufacture the products, and this design and manufacture products goes to the market. These markets are selling guys directly push to the customer, and that's why the customer is unsatisfied. Most probably the customers get an unsatisfied from the given component, because the customers needs are not identified, not uh, included in your products. That's why this is called as the product out approach. In the traditional way we can go the design in this way. Now today the new product introduction processes. Okay, to overcome this disadvantage of the traditional design approach or processes, we use the market in approach. Okay, in that, okay, latent needs or the customers need identifications. First go for the customer need identification, identify the customer's needs. Again, that needs we can design and develop the products and manufacture based on the customer's needs. Then this product is pulled by the market. All the identifications, all the needs are comes from the customers from the markets, and then we satisfy the customer. These are the market in approach for the new product processes. That's why it is the one of the part for the design for manufacturing. Generally it's called as the DFM processes. Okay, what are the design for manufacturing? Okay, what are the basic definitions for the design for the manufacturing? Design for manufacturing is a design techniques for manufacturing each of an assortment of parts that would constitute the final product after the assembly. These are the general or specific definition for the design for the manufacturing. But what are the design focuses on generally the minimizing the complexities. Here called as the minimizing the complexities involved in the manufacturing operation, as well as reducing overall part production cost. There are the two basics goals for the design for manufacturing is called as a minimizing the complexity and parts production part cost. Okay, and the what are the example for the design for manufacturing? The simple example is called as the mixer in your kitchens uses the standard motors but having the multiple jars plus juicers to satisfy the kitchen's requirement. Generally use the modularity concept in these products. Okay, one of the single mixer uses the different jars for different purposes in a single motors. Okay, this motor is a standard one for each and every jars. That's why this is the part for the design for manufacturing, not use the multiple jar for multiple motors. Okay, this is the good example for the design for the manufacturing. Okay, now design for manufacturing, the goal is to reducing the manufacturing cost and improving the product quality is the first approach for the design for manufacturing. You can reducing the cost of the manufacturing and improving the product quality. Then manufacturing cost is a key determinant of economic success of the product. That's why it is the key determinant of the success of the products. Then DFM requires concurrent engineering team approaches. Here is a concurrent engineering called as the CFT. Use CFT team, cross-functional teams are comes together to work on a project or products. So DFM requires the concurrent engineering teams. DFM uses the modularity concept to minimize the number of components or to reducing the cost of manufacturing and the product cost. Okay, and last is the DFM is performed throughout the development processes. Generally the DFM start with the concept phase, so it is comes under the conceptual designs as well as the embodiments and the detailed design, but it start with the concept phase of the engineering design processes. Why DFM we use? Okay, for new or improved product to be designed, manufactured and offered to the customer in a shorter amount of time is called as the first is a shorter amount of a time is the important factor for the DFM. That's why we use the DFM. So DFM, when we apply the DFM, then we use we offer to the customer in a shorter amount of time products. Okay, second, DFM helps to eliminate multiple revisions and design changes that cause program delay and increase the cost. Second is the reason, that's why we use the DFM. You can changes that causes the program delay and increase the cost. With DFM, the design is often more comprehensive efficient to produce and meet the customer's requirements the first time. These are some of the causes. That's why we use some DFM processes. Okay. What are the benefits of the DFM processes? Okay. We use a short as the benefits. We can reduce the rework by 20% when we apply the DFM concept in your products. Okay. Then we can reduce the time to market by the 10% and reduce the production cost by the 6%. This is the overall the benefits of the DFM, generalized benefits of the DFM processes. That's why you can reduce the cost of the manufacturing also. So we can reduce the rework activity, reduce the time to the market. Your customers get satisfied when the product offered or product given to the customer within that times. This is called as the delivery satisfactions. Okay, and we can reduce the production cost by the 6%. Okay, then what are the opportunity for the changes in a DFM? Okay, here the graph shows the x-axis shows the times with the starting with the concept phase and end to the customers, and the y-axis shows the opportunity from low to high opportunities. Now this line shows that the start with the high towards the customers ends. Okay, so there is a more and more opportunity to change the product or to develop the product in the concept phase only. When the product is goes to the customer, there is a very low opportunity to change it. That's why here is the chance to change the products or change the component in a concept phase. These are the major opportunity given by the DFM process. Okay, now what are the DFM methods? Here we study the this flow diagram of the DFM methods. Okay, next lectures we discuss the detailed in the DFM methodology, generally called as overview of the DFM processes. Okay, here is called as the proposed product designs. We start with the first step is called as eliminate the manufacturing cost. Second step is called as the reduce the production cost, reduce the cost of assembly, reduce the cost of supporting productions. Then consider the impact of the DFM decision on the other factors. There are the different factors. So recompute the manufacturing cost. Then if this okay or good enough, then acceptable the design. Otherwise we start with the iterations for this reducing the cost and the other components. These are the generally way of the DFM methods. Okay, now what are the generalized guidelines for the DFMs? Okay, we start with the first is to minimize the total number of parts. Okay, we can minimize the total number of parts in your assembly in the or in your products is the first guideline, is a major guideline for the DFM processes. Then standardized component, use the standardized components in your product and assemblies. Then use the common parts across the product lines. Use the common parts, so you can reduce the cost of manufacturing also or manufacturing processes also by using the common parts. The standardize the design features. You can standardize the design features. You use the fillet, reduce the shaft corners and the angles in your components. So we use the fillet and the blunted areas. These are the standard design features. Then aim to keep the design functional and simple ones. Sixth guideline is the design part to be multifunctionals. So the components are used. Then design part for ease of fabrications. Then avoid the excessively tight tolerances. So you can use the avoid the excessive tight tolerance in your assembly and minimize secondary and finishing operations. Okay, only you can produce a component in a single manufacturing processes, so you can reduce the secondary and the finishing operations. And last is called as utilize the special characteristics of the process. These are the general guidelines of the DFM. Okay, we go for these guidelines, then we achieve this DFM applications. Okay, now come for the design for the castings. Okay. What are the conventional casting processes? Here is the diagram shows this conventional casting processes. There are the different parts of the conventional castings. Okay, here is called as some cope and drag as this, and the pouring basins to spool, the gate, runners, mold cavity is there, the bland risers and open risers, and the vent are there. Okay, these are the general casting processes. Okay, when molten metal poured in the pour basin, this comes to the sprue to the choke, in general is called as the sludge wells, and gate to the bland risers, then they enter to the runners, this runner to the mold cavity. Here is the called as the cores are used to uh, produce the hollow part in your castings. Okay, the vent are is there, and the risers, one of the important functions or one of the important parts in the casting is the risers. Okay, and the mold cavity gets solidifies, and we remove this casting from this molding. Okay, these are the general practices for the or conventional practices for the casting processes. Okay, now design for castings. The chief design issues for the molds are to provide an entry for an molten metal into mold throughout the laminar flow. We can maintain the laminar flow in these processes. That's why we can eliminate the erode in the mold surfaces. So we can maintain the laminar flow. These are the special design issues. Then second is to provide a source of molten metal until all the casting has been filled. Cores are suitably placed to provide hollow features for the parts. Okay, and liquid metal shrinks on solidifications. Supply of molten metal is available to compensate for this shrinkage. Generally, the risers are used to minimize the shrinkage defects. These risers having the different types is called as open riser, side riser, or a blind risers. Okay, now what are the design guidelines for the castings? Okay, there are the shapes of the castings. The section thickness should be uniform. The section thickness should be uniform in order to avoid the shrinkage cavity. Thicker section creates hot spots in castings. The greater volume required more time for the solidification. That's why you can reduce the we can maintain the uniform thickness in the castings. Okay, redesign to reduce thickness and use of cores for the casting processes. Then draft allowances. Draft allowance generally use the 1 to 3 degrees for the is required for pattern as well as the casting from permanent mold. The draft aid to remove of part from the mold, generally 1 degree for the sand casting and 2 to 3 degree for permanent mold castings. To minimize the use of the cores, you can minimize the use of the cores are this. Okay, solidification stresses can occur on a different section of the casting, solidify at different times and rates, and proper machining allowance on the sand casting are some of the short guidelines for the design of casting. Generally we use the geometric simplicity, also avoid the unnecessary complexity, simplifies mold making, reduces the need for cores, and improve the strength of the casting also. And second, the corners, also the sharp corners and angles should be avoided because they are source of the stress concentrations and may cause hot tearing and crack in castings. A fillet should be designed on inside corners and sharp edges should be blunted. These are the some of the design consideration in the casting processes. Okay, then guideline for the design of the castings. Okay, design features that can eliminate the shrinkage. Design features that can be eliminate the shrinkage. Okay, the transition between the two sections. These are the section transition between the two sections of different thickness. There are the thickness. There are the changing in the thickness should be gradually. Should be gradual. These are the poor design. These are the good design because this section thickness should be gradual ones. The way shape changes in wall thickness should not have taper exceed 1 to 4. Okay, the local heavy sections cause omitting the outer radius at the corner should be eliminated. Here is the outer radius of the corner should be eliminated. We can use these designs again. These are the good designs. We can maintain the cross section throughout the processes. Here is the cross section is very high, so very high cross section maintain contains the more metals, so this metal required more time to solidifies than this and this part, so they create this shrinkage cavities. So these are the good designs. A strong hotspot is produced when two ribs cross each others. Here this strong hotspots is produced between the two ribs cross each others, resulting in the shrinkage cavities. Okay, to eliminate this, we use by using offsetting the rib. We can offset these ribs to eliminate the things. Okay, these are the some of the design guideline or design features that eliminate the shrinkage defects in the castings. Okay, thank you for watching.